Okay, so now we're going to go over the um, side-side angle, no solution case. So what is it going to look like when there's no solution to the problem? Remember, that was one of the possibilities if one of your sides was too short. So let's look at the given information. Let's solve the triangle when we know that angle A is 70 degrees, angle B is 12, and side B is 12, and side A is 4. So again, of course, the very first thing we're going to do is draw a picture. So I'm going to try to construct my triangle so that it looks like it has about a 70-degree angle. So that's, pretty big. Not quite 90, more than 45, so somewhere in here. It's a pretty big angle. And then I'm going to kind of approximate these sides. And I'm going to leave that right here for now. Now remember, we're going to label my angles. Here's angle A. Here's angle B. Actually, let's put B down here. And then we'll put C in here as well. Okay, and so I'm going to take B and move him back over here. So we know that angle A is 70 degrees. We know that side B is 12, and we know that side A is 4. Okay, so think about that. If this side right here is 12, it doesn't really make sense that side A would actually be long enough to ever reach the other side. That's why I kind of drew it short. I tried to draw it relatively to scale. 4 is about 1/3 of 12, so that side looks like it's about 1/3 of that length. So it looks as if this side is going to be way too short and it's not going to reach the other side. But how can we check for sure? Okay, what we want to do is make a comparison to the height of the triangle. So remember, our height extends perpendicular to the other side. Okay, so that's my little h right there. So we calculate it by going, finding the value of the side b times the sine of a. So that would be, in this case, 12 times the sine of 70, and that's 11.2. If I multiply that out on my calculator, if I compare that to the side length of A is 4. 4 is less than 11.2. So in this case, side A is less than the height. And when that happens, there's no possible solution to the triangle. It's not going to reach the third side, and so we can't find any of the other sides. We're done. This is actually kind of a nice, easy case. We don't have to go through all the work of using the law of sines to find everything because we can't. Yay! Okay, so we got one more example, and the last example is the hardest example. It's what we do when there's two solutions, okay? There's a lot of work that's going into this particular problem, so bear with me. And again, if you need to stop, rewind, and listen to it again, please do that. It'll really help. So let's solve the triangle when we know that angle A is 30 degrees, side B is 10, and side A is 6. Of course, we're going to start by drawing a picture. I guess I can't reiterate that enough. So let's label some angles here. So here's A, here's B, and here will be C. Okay, so we said that angle A was 30 degrees. We said that side B was 10, and we said that side A was 6. So side A is clearly shorter than side B, but we still need to make sure that it is long enough, right? So let's see what happens if I do this. Okay, here we go. We'll get that guy. And let's draw in the height here. We want to make sure that side A is at least bigger than the height as well. If it is bigger than the height, then there might be two possibilities to solve this triangle. So that's where we're going to start. Let's find the height. We know that the height is equal to b times the sine of a. So that's 10 times the sine of 30. I know that the sine of 30 is 1/2, so 1/2 times 10 is 5. So in this particular case, the height is 5. Now, if this here is 5, right, side A is 6, the height is 5, side B is 10. So we have this situation where A is in between the height and side B. So we know that there's two solutions possible. And I want you to visualize what those two solutions are, okay? So I'm going to highlight this side here that's 6, and we're going to change its color. And then the other thing that I'm going to do is make a copy of that little segment here, and I'm going to put it right up here, and I want you to think about the other possibility for that segment. It's going to look about something like this. Remember, we'll put that little angle in here, okay? Now these two segments here are exactly the same length, right? You can even kind of visualize it. It looks like an isosceles triangle here. They both have a length of 6. So the two triangles that could be created are basically sitting here, this little turquoise one, right? Or the whole big triangle. So we're going to find both of those. Now both of those triangles are kind of dependent upon what's going on with this opposite side, but that side here that's the length of 6, where that is actually going to control the size of angle B. And B could be here, and it would be this big. Or if my side was sitting over here, B could be sitting over here as well. And then we have a different angle for angle B, right? So we're going to find both of those angle B's and then proceed to find the other sides of the triangle. All right, so bear with me again as we go through this process. All right, so the first thing we're going to do, like I said, is find that angle B, right? Remember up here, here's my angle B right here. So we know angle A and we know side A. We know side B, we're going to find angle B. So we set up the law of sines. The sine of B over 10 is going to equal the sine of 30 over 6. So I multiply both sides by 10 to clear the denominator so that I can isolate the sine of B. Okay. So that's going to simplify to sine of B is equal to 10 times the sine of 30 divided by 6, and then that's equal to 0.833333. And then, of course, we take the inverse sine to get the angle. Once we do that, we get that the angle is 56.4. Now remember, that's only one of the possibilities for angle B. So I'm going to go back into my diagram here, and let's actually put that in. 56.4 degrees could be, and I'm going to make that real small here so we can squeeze it in. And I know it's tiny, but bear with me here. This possibility is 56.4 degrees, but that's the first possibility. So we'll call that B1, right? Remember, there's a B2 that's going to be possible as well, or in other words, a second value for the angle of B, and that's going to be sitting over here. Now let's think about how we might find that value. Remember how we talked about this triangle being isosceles? And since it's isosceles, the base angles are going to be exactly congruent. So if this is 56.4 degrees, this is going to be 56.4 degrees. And if that's true, then what will this angle right here be? Well, since they form a straight line, this angle right here would be 180 minus 56.4 degrees. So that's how we find the second possibility for angle B. Okay, so over here, there's two different angles that meet the condition. So we called one of them B1, and the other one we're going to call B2. And we find that by subtracting B1 from 180. So we're doing that calculation right here. B2 is equal to 180 minus 56.4, or is equal to 123.6 degrees. So let's go back up to my picture, and we'll put that in as well. 123.6 degrees. And again, I'm going to make that nice and tiny so I can squeeze it inside my triangle here. I might make that 30 nice and tiny too, so we can fit more of that in. And I know it's small, but oops. If I can move it, I guess I can only move the line. Here we go, here we go, here we go. We got it. Okay, put that back. So this angle right in here is 123.6. And I think it's useful to label the triangle so you can get an idea of what it is that we're finding next. Okay, so the next thing we're going to find is the two angles, angle C. Okay, so there's this angle that's possible for angle C, or there's this little teeny tiny angle that's possible for angle C. And since we have angle A and angle B, we're going to do just like we did before, add those together and subtract from 180 to get the two different possibilities for angle C. Okay, so if angle B was 56.4 degrees, then angle C would be 30 plus 56.4, and then we'd subtract that value from 180. So 180 minus 86.4 is 93.6 degrees. Or if angle B was 123.6, then we'd add that to 30. We get 153.6, and we'd subtract that from 180, and we get C would equal 26.4. And again, that fits with what we see in the picture, 93.6 or 26.4, right? This is my 26.4 degree angle, really tiny. This is my 93.6 degree angle, a little bit bigger. Okay. Now that we have the two possibilities for angle C, we can find the two different possibilities for side C. It's either going to be this whole length right here, or it's going to be this little teeny tiny length right here. If my triangle was only this big, this would be angle, or this would be side C right here. Okay, and we use the law of sines just like we did before to find both of those side C's. So we're going to set up the law of sines. So we'll say 6 divided by the sine of 30 is equal to C1 divided by the sine of 93.6. We're going to multiply both sides by the sine of 93.6. I don't think I typed it in here, but we're going to do that multiplication so we can clear the denominator, just like we did before. So C would equal 6 times the sine of 93.6 divided by the sine of 30, and we get 11.9. Now remember, that's all based on the assumption that angle B was 56.4 degrees. So go back up to your picture and see if it makes sense. If this angle is 56.4 degrees, it makes sense that this is 11 point something, right? It's the longest side in the triangle. This side is 10, this side is 6, so it makes sense that that's 11. Now the other possibility is for side C2. So this time angle C is 26.4 degrees, so we use that in my law of sines. So 6 divided by the sine of 30 is equal to C2 divided by the sine of 26. Multiply both sides by the sine of 26.4, and we get side C2 is 6 times the sine of 26.4 divided by the sine of 30, which is about 5.33. Again, relate that back to your picture. That would be this little length right here, 5.3, and that totally fits with what we see in the picture. Okay, again, I know this was an awful long process for one problem. We only have to do a couple of these, but once you do a couple, you'll totally get it. Okay, and again, re-listen and re-watch some parts of this video, and I think it'll really help make sense of the process.